From Pure Advantage, I'm Simon Miller, and welcome to our podcast, the destination for leading-edge discussion with some of the world's experts in green growth, regenerative development, business, and climate change. Our Regenerative Future, Season 2, looks at O Tātou Ngāhere, our forest, and stems from our collaboration with project partners Tānei's Tree Trust, New Zealand's preeminent native forest experts and scientists. Together, we've taken a deep dive into the regeneration of native forests as a source of natural, spiritual, and economic value. The purpose of this series is to spark cross-sector dialogue and get people thinking about the potential for native forests in a regenerative and restorative economy. For listeners interested in a bit more, we produced a short documentary, O Tātou Ngāhere, and compiled an array of expert contributions and videos, all hosted and freely available on pureadvantage.org and taneistrees.org. It's great to have you with us. Thanks for being on the journey to Our Regenerative Future Season 2.
Across the country, there's growing concern about the speed and volume of permanent pine forests being planted for their carbon sequestration potential. So-called carbon farming, this forestry is incentivised by the Emissions Trading Scheme, which favours fast-growing exotic species such as radiata pine over indigenous forests. Partly this is because so little is known about the carbon potential of native species compared to the much-studied Pinus radiata. However, new research reveals that well-managed planted indigenous forests are better at sequestering carbon and faster growing than is commonly understood. The research by Tānei's Tree Trust and Pure Advantage indicates that the difference between pine and a well-managed planted native forest is much smaller than is often suggested. Moreover, planted native trees will store carbon at a growing pace as they age, as well as enhancing natural landscapes, biodiversity, and cultural values. Well, to discuss this research, I'm joined by authors of the paper, which is called Carbon Sequestration by Native Forest, Setting the Record Straight. And those authors are Professor Warwick Silvester, he's the Emeritus Professor of Biological Sciences at University of Waikato, Mark Kimberley, a forest statistician formerly with Scion, and Dr David Bergin, a forest restoration ecologist and trustee of Trees That Count. Well, that's quite a mouthful, Warwick, but perhaps tell us about Tānei's Tree Trust. Who is the trust and why did you do this research?
Well, a little over 20 years ago, a group of us got together to discuss the alarming state of the native forest resource. Many will know that over 80% of the native forests in New Zealand have been removed over the last 1,000-odd years. And about 30 years ago, of course, we had the tree sitting group who successfully prevented the logging of old-growth native forest. And that set about a movement to preserve every little bit of native forest from exploitation. So we went from one extreme to another extreme. The group got together to try and present a view of native forest that was all-encompassing, to value the forest for all of its properties. And the point of difference that we established was that we in New Zealand have some of the most amazing timber trees of the world. Think kauri, think totara, think the beech species, think rimu. Beautiful. And we began importing all these tropical trees to take the place of our beautiful natives. So our point of difference is that we certainly move to preserve the native forest and to grow the native forest, and also to allow native forest species to be managed for production. So there is a production element in what we say. But above all, we've produced masses of evidence to show that you can grow these trees and how to grow them. So the point of difference, as I say, is we advocate not only for all the non-timber values or the ecosystem services of native forest, but also for the opportunity to be able to grow them for production.
And suddenly we've discovered the carbon sequestration potential of forests. I say suddenly because it's become very popular, but, has always been there. And you've created a database of indigenous forests. Tell us about that database, the plantation database that has been developed by Tānei's Tree Trust.
Perhaps I could step in here.
So David,
Vincent, Tānei's Tree Trust has got this, what we call the Tānei's Tree Trust Indigenous Plantation Database. And it really stems from surveys that started while I was at Forest Research Institute in the 80s. We completed another survey of planted native stands throughout the country in 2010 as part of Tānei's Tree Trust. And that really is providing the growth data from over 120 plantings of natives throughout the country that underpin the carbon modelling that that is part of this current research. The plantings, they range from quite small groves to slightly bigger stands of 1 to 2 hectares. Yes, it doesn't sound much, but that's what we've got to work with. There's been, of course, thousands of plantings of natives over the years, but a lot of them have been lost, if you like, in terms of we don't have the records of when exactly they were planted and where they occur now. And after a while, of course, a planted stand to some degree starts to look like a natural stand, so we're not always necessarily sure of the history of those stands. So we're having to be quite selective about what data goes into our database. Nevertheless, over the last decade or two, there's been a lot more planting, and we're quite keen to make sure that we start capturing a lot of that data as well.
David, this is distinct from the conservation estate where we might have had natural stands left for long periods. You're talking about newly planted. How recent are these planted stands that you're talking about?
Invariably, most of these stands are on private land, Maori land, and on council land in reserves. I don't think there's very many, if any, on the conservation estate. What we're really interested in is the growth rates. So it doesn't really matter where they occur. The most important thing is that we know what year they were planted, and then if we can get some idea of how they were managed over the years. We've got stands that date back to 110 years old, just 1 or 2, but then a lot of them are now, sort of 10 years or less as well.
So you're building a database of knowledge about where these stands are and their growth rates. It's then another exercise to calculate their carbon sequestration potential. And I guess I don't really know how that exercise is done. Mark, how do you assess the ability of a stand to absorb carbon dioxide?
Well, so a tree... the matter in a tree is basically 50% carbon. And as a rough rule of thumb, for every cubic metre of wood in a forest, to create that cubic metre of wood, the trees must have removed around 1 tonne of carbon dioxide from the atmosphere. So through the process of photosynthesis, the tree uses sunlight to power the whole operation. It extracts the carbon dioxide from the atmosphere, releases the oxygen back, and uses the carbon to build up the forest. So that's the rough rule of thumb. 1 tonne of CO2 is equivalent to 1 cubic metre of wood. But we've got more accurate conversion equations that we use that were developed by a team of scientists at Scion over quite a few years, using samples from felled or fallen native trees from all over New Zealand. So basically they would go in and cut up trees, take samples from them and dry them, weigh them, work out how much weight there is, and 50% of that weight is going to be carbon, roughly, and then and relate that to the volume of the tree. We have these conversion equations, basically. All we need is a measurement of the diameter and the height and the species, and we can work out how much carbon is in that tree. So we go to a planting, a plot on the ground, which is of a fixed area plot, and we count the number of trees inside that plot to give us how many trees there are per hectare. Then we measure the diameters of those trees and their heights, and we apply our carbon equations, and we can calculate the total carbon in the tree, including the roots and the bark and foliage and branches. And we can calculate from that how much CO2 that tree must have removed, or that forest must have removed from the atmosphere during the course from the time it was planted through to the time that we measure it.
Do you have to apply some sort of time component to this? Because I imagine that they absorb carbon at different rates at different stages of their life.
Yes, so you can imagine when you first plant some seedlings in the ground, they're not absorbing much carbon. They take a while to get established, and it's only really when their crowns are fully developed and the canopy is covering the site, there is with no gaps, that they're really growing and absorbing at the maximum. So so you really have to wait several decades before you reach that kind of maximum level of carbon sequestration. But then that can then continue for many decades into the future. So generally we assess the carbon at an age, say, of 50 years. We can extrapolate the values we're getting to work out how much carbon we expect to stand to sequester over, say, the first 50 years from planting, and we work that out usually as a tons of CO2 per hectare per year kind of value.
Mm-hmm. Warwick, we now have this research that has been done into just how effective native forests are at absorbing carbon. Can you tell us what this new paper has found?
A lot of the talk about sequestering carbon is about planted stands of radiata. For an appropriate comparison, we need to compare native species that have been planted, and we have that database. And the numbers that have come out from that, just to throw some numbers up to give people an idea of what we mean by these numbers. We're talking about tons of carbon dioxide assimilated per hectare per year by a stand of trees. A number of 5 or 6 is quite low, and we admit that is low, and beginning growth of native species is about that order, and we've measured that as well. A number of 10 starts to get up there. A number of 15 is considered reasonably high. When you get into the 20s and even the 30s, it's very high. And for native species around the world, the numbers that look like the 10 to 15 sort of area. Mm-hmm. And those are the numbers that we get for native species. So the notion that native species are slow is based on 2 things. One is they definitely are slow to establish, and they require quite a lot of management to establish native tree species well. The second thing is a lot of measurements that people have been made on remnant stands of native forest, which of course are the bits of land that weren't available or weren't useful for farming. So they're the poorer hill slopes, the skeletal soils of the hills, where we've got remnant stands of native species, and measurements of those will indicate, reasonably slow uptake. But to make an adequate comparison with radiata, we believe we should be comparing managed planted stands of natives, and that's what we've done. And those are the numbers that we've achieved, and they're of the order of once established 15 to 25. So we're right up there, and this equates very well with native species right around the world.
What you're saying is that hitherto the understanding of the carbon sequestration potential of native forests has been based on effectively scrubland. So we're talking manuka and kanuka on poor soils, and that data has been kind of the given understanding of the potential for native forests. And this research that you've done now on these planted managed stands is revealing that the potential is much greater. In fact, in another almost comparable with pine forests. Is that what you're saying?
Yes, well, the lookup tables for the ETS for natives refers only to regenerating scrubland, and that's of the order of 6. Those are the only sort of published lookup. Those are the values that are used for native forest. There's no doubt that native species don't get underway until the order of 20 to 30 years, and by then they're up in the region of 15 to 20 or 25. And we've got lots of figures which show that.
Mark, Warwick referred to lookup tables just before. What are lookup tables? Why are they relevant to this discussion?
Well, the MPI, Ministry of Primary Industries, they have published some tables that people use, small growers use for estimating the amount of CO2 they have removed from a stand of trees. And there are lookup tables covering various different types of forest, including radiata pine and Douglas fir and so on. And there's one table for indigenous forest that has to be used for all indigenous or native forests. But this lookup table, as Warwick mentioned, is really based on regenerating shrubland, Manuka Kanaka shrubland. It has a value, roughly the mean carbon CO2 per hectare per year is 6.5. So 6.5 is quite low. As Warwick said, our planted data from planted species such as Kauri and Totara and Rimu are more like 15 or 20. And just as a comparison, the radiata pine lookup tables are in the mid-20s. So, so that's why if you plant native trees and you apply the MPI lookup tables, you'll be way under predicting the amount of carbon that your planted native trees will probably be sequestering.
Why does that matter? What are the implications of that data?
So those tables are used for the ETS, which I'm maybe not the best person to talk about, but
give it a go.
Okay. The ETS is a means of people. If you're growing forest, you can sell your carbon credits from those growing trees to people who need to buy them to cover their emissions. So it's a system the government has put in place to try and encourage people to grow trees to sequester carbon, which will help New Zealand meet its commitment to reduce emissions, or to reduce the net emissions, which can be either achieved by either reducing emissions or by increasing sequestration through growing trees. So if you're a forester and you're looking at growing, planting some trees and claiming these credits and getting some income from them, which you can then get like a regular stream of income coming from your trees, which are just growing and absorbing carbon. I mean, if you grow radiata pine, you'll get a pretty good income because the carbon is pretty high. The level of sequestration is very high, and the lookup tables are pretty accurate for radiata pine, and because they're developed using a lot of data and are very reliable. So, but if you're growing natives, you're at a big disadvantage because you're using lookup tables that were developed for regenerating shrublands, which are not really typical of the sort of forest you would be planting if you were planting natives.
David, this has pretty big implications for farmers and for foresters and landowners. And the data that you've produced, these insights that you produce, but they'll only be useful if indeed MPI adopt them. Is that right? You know, what are the chances of you convincing MPI to include this new data in their lookup tables?
Well, we would encourage MPI to consider perhaps a second set of lookup tables for planted stands. And and the caveats around that, of course, are that they're planted on reasonably good sites and that they're well managed. And we would expect, if that's the case, that they would grow considerably better than the regenerating stands. And even our plantation database is reflecting a lot of stands that have been planted on much better sites than regenerating forest on marginal lands, upland sites. With skeletal soils, that sort of stuff. So I think, having, retaining the current EDS tables for regenerating scrublands, and then having using our database to develop a second set of growth figures based around planted stands would be quite a good thing for MPI to consider for the ETS.
But why does this matter, Warwick? Why does it matter that we are truly understanding the carbon sequestration potential of native forests?
Well, let's think of the word slow. When someone says something is slow, it's got to have meaning. Its meaning can be in an absolute sense, and its meaning can be in a relative sense. And the term slow is generated because, there's no doubt, native species grow slower than radiata. Let's think why. Radiata has nearly had 100 years of research into managing it, genetically improving it, and producing a timber species that is quite outstanding. And there's no doubt native species will be slow compared with that, where virtually zero work has been done into the management potential of our native species. So it matters because when someone on a farm is told that you don't want to plant native trees that are slow, they read that as being an essential truth. And there's no doubt, compared with radiata, they are. But what they don't take into account is all the other properties of native forest. And we'll talk a bit more about that later on, perhaps. But it does matter that we use this pejorative term slow. And we could actually come up with some real figures for what slow means.
Mark, could you describe to us what happens with a stand of native forest over time and its ability to continue to absorb carbon for a longer period than radiata pine?
Yeah, so, a Kari or Remu stand at age 50 may be sequestering at that point in time around 30 tonnes per hectare per year. And it will continue to do that, we think, for quite a few more decades beyond that point. Eventually, all forests will slow, the growth eventually will slow. Eventually, it reaches some kind of equilibrium point, but that may be, for natives, is far beyond the range of our data. So I can't really speculate too much on that. But certainly for a very long period of time, natives will continue sequestering carbon for probably hundreds of years, in fact.
How would that compare to a plantation of exotics?
Well, it depends on the exotics you're talking about. Radiata pine, for example, sequesters very rapidly from a young age, peaks quite early, and then continues to sequester at a high rate, but gradually declining. And radiata pine, I think its longevity is probably around the 100 to 150 years or something like that. So, certainly within our lifetimes, it will continue pretty well. But looking into the distant future, it doesn't. At some point, a radiata pine forest will actually get old, and what happens beyond that is a bit we can speculate, really. Native forests can carry. We know, there are. We look at our natural forests; many of them are many hundreds of years old and carrying quite high levels of carbon.
The expectation is that forestry would provide a lot of the heavy lifting for our emissions reductions up to 2030. In fact, as I understand it, 2/3 of our emissions reductions to 2030 of our nationally determined commitment is through offsetting, through forestry. So there is a high expectation, isn't there, that exotic forests like Pinus radiata forests are going to do a big job for us. Is there an opportunity here, based on your research, to introduce native forests, indigenous forests, into that kind of early win to 2030?
Basically, if we plant at a higher stocking, a higher density of planting, we can actually get quite good sequestration from a reasonably young age. And one, but generally it's quite expensive to do that. So we tend to plant trees reasonably far apart in order to basically save costs, knowing that it means that the early growth won't be that good, but eventually when those trees start maturing, they will sequester quite a reasonable level of carbon. But one thing that people can do, and often do when they plant natives, is to plant them as a mixture of shrubs and tree species. So the shrub seedlings tend to be less expensive. So things like manuka, you can plant manuka at reasonably high stocking, with interplanted in between the manuka tree species such as kori or kotaro or rimu. And those sort of mixed plantings actually can sequester around 15 tonnes per hectare per year from quite an early age. So that's one way we've found that natives can actually contribute, say, over the first 20 years of growth, quite a reasonable level of sequestration.
If I can just add to that, and I totally agree there, Mark. But you did touch on it, that it's if it's going to be at high density, we just know that the cost per hectare for planting natives is very high, and I guess one of our concerns is that if we are to address one of the Climate Change Commission's recommendations to be planting something like 300,000 hectares, or establishing 300,000 hectares of native forest over the next 15 years or so, how are we going to do that? And we're not going to do that by planting, and certainly not planting at very high density. Planting is going to continue as a significant component of establishing native forest, but there's vast areas of our hinterland that some are arguing is marginal to pastoral farming and is erosion prone, where it's considered that afforestation of those sites would benefit a whole range of values. How are we going to do that? And this is where I think we really need to encourage regeneration. And therefore, that's why we're sort of suggesting that the current ETS tables are reflecting what the sort of growth rates we would get from the regeneration. But how can we also integrate planting, like seed islands, into planting, along with pest animal control, bird predator control, increasing seed production, bringing back seed sources into that mix to help nature do a lot of this work for us, So that's part of that heavy lifting that we're sort of talking about as well.
So it's not just a binary question of planted versus regenerating. It's what kind of tree is regenerating.
Yes, definitely. I mean, the potential of the forest to store carbon depends a lot on how high the trees in the forest are. So shrubland, manuka, for example, it reaches quite rapidly, grows up to about 6 meters in height, and then pretty much stops. So that's why its carbon potential is fairly rapid to begin with, but has a fairly an upper limit. Whereas, say, a totara stand will keep growing, the trees will keep growing taller and taller for hundreds and hundreds of years.
We're not anti-Pinus radiata. We believe that there is a big role for radiata in the short term to sequester carbon, and it's absolutely proven, and it will work. But what we don't want is it to be done exclusively and leave out what we believe is the necessity to restore a lot of our native forests. So it's not just the carbon and ETS that drives us. there are a whole lot of other issues.
Well, just expand on that, because you mentioned before about when I asked why does it matter, you hinted at some of the other values that are derived from indigenous forests. Just to expand on what those values are.
Well, of course, one of the major ones is the biodiversity one. Within the native forest, as it matures, we get increasing biodiversity, we get habitat available for the widest range of native species, both plant and animal, and we establish a whole lot of other values. The values on soil stabilization, on water quality, and the values to do with environment, with a landscape. There's a landscape value that we all value to do with native forest. So the wood that is available, and we advocate for some of it to be harvested, is only very much part of the story. And let me just add a little rider to that, and sort of cut to the chase here, that the numbers that we are bringing out are done by a bunch of volunteers. Mm-hmm. The government ministries have not actually done a significant job in measuring what native species are able to do. So the values here are done by Tarnished Tree Trust, which are a bunch of volunteers who have to go out and grab money from various granting agencies to do all this work. And we've established, I think, a credibility in this area due to the fact that we have got some very good science behind it, and we are trying to balance up the books to say that our native forests are a wonderful resource in all respects. The non-timber values related to native forests are legion, and I can refer you to a book that we've just published on 100 pages, which establishes all of these values. There are a legion of them. And anyone who walks in native forest will appreciate those, as well as the timber values.
It was a surprise to me listening to David talk in the O Tātou Ngāhere series about the lack of knowledge of our native forests, despite having a forest service for decades and having Scion, Crown Research Institute, and many university departments dedicated to studying forestries and trees. We know so little about our native forests. David, is that because so much of our effort has gone into understanding the wonderful Pinus radiata?
I think to be fair, there has been a lot of work going on in native forests from all sorts of angles, from various tertiary institutes and CRIs. I guess where Tarnished Tree Trust comes from is that we are taking the applied bits of that research and trying to get that information in a context that we can appeal to landowners, iwi, policymakers and what have you, about the potential for, the greater potential for our native forest than is realised. So, our challenge really is to take a lot of that information out there. Yes, sure, identify the gaps that are still there that we need to know more about how some of these species tick, and then try and get research programs underway to fill those gaps. But then, just as importantly, get that information out in such a way that we can appreciate where natives can be grown successfully to meet the multiple objectives of carbon and timber and non-timber values that Warwick has talked about.
One we haven't touched on is the impact of fire. So much of the Californian carbon sink went up in smoke this year. Fire must be an imminent danger for plantation forests that, again, an indigenous forest will be more fire resistant. Am I right about that?
Well, not necessarily. It really comes down to the species, and with climate change and increasing temperatures, we need to be aware that some of our certainly our cereal species like Manuk and Kanaka are quite fire prone. The answer is around trying to establish a diverse forest species, where it has a mix of low, medium, and high flammability species, and capitalising on that. So, we're working at the moment on a fact sheet which is talking about building resilience into our native forests, and that's about having green fire breaks made out of, which are planted with species that are got larger, thicker, green leaves that are more fire resistant than others. But I guess that, it comes back to my point that we really want a diverse mosaic land use, rather than just one huge monoculture of a single species throughout our landscape. And we would really support more natives and mixed natives, not necessarily single species stands. They are mixed native forest types, which is mimicking what nature had here originally.
So just want to touch on the point you mentioned, David, and that is, we don't want to leave the impression that we're going to grow single species stands of natives and clear fell them. That's the last thing we're advocating for. As David said, we want mixed stands, and the thing that we have advocated for and written the book on, and that's continuous cover forestry, maintaining the cover of forest during harvest. And we've done several examples of this in the north with totara logging, and we've got videos on this, and it's absolutely brilliant. You can take single trees out, and within a year you can't see where they've been taken from. That's continuous cover forestry, and we certainly don't advocate for clear felling of native species.
Your description of a mosaic could include pastoral and agricultural activities, couldn't it? And I thought it was interesting the way that Beef and Lamb were very proud to say that if they took into account their native stands, such as the QE2 stands on many farmers' lands, that they were approaching carbon neutrality as agriculturalists.
Yeah, absolutely. I mean, and it's about basically, matching your land use to your landform, and so that you've got appropriate production of, those easier slopes and the flats and what have you, which will be horticulture and pastoral grazing. And even in amongst that, there are going to be areas where you'd want to have forest and wetlands and riparian areas where natives can play a major role in terms of biodiversity and connections and corridors and all that sort of stuff, through to your backcountry, hill country, where some of it is going to be okay to put into radiata pine because it's easy to access and close to ports, but a lot of it would probably benefit from going into permanent native forest, and with the option of continuous cover forestry harvesting in the future.
And as a former Parliamentary Commissioner for the Environment put it in a very useful publication that he put out entitled Weaving Resilience into Our Rural Working Lands. So it's a mixture of appropriate places for appropriate species.
Exactly.
You'd almost call it regenerative.
Yes, almost call it regenerative. We've heard that word.
When you drive around the motorways of New Zealand, you see this beautiful planting by Wakatahi. Is any of that countable in your planted database?
Within the database, we have various small stands similar to those. A lot of those plantings are more shrub-type species, and we do have data on shrub species, which planted shrubs we find, as I alluded to, can sequester quite rapidly for quite a few years, but they do have a sort of upper limit.
Yeah, it's interesting that over the lifetime of my career, I've seen the planting on roadsides change dramatically from some pretty awful stuff, growing ivy and exotic trees, and now we've got almost exclusively a native cover. It's mostly in shrubs. We've been advocating with various agencies to plant some trees amongst it as well. And a lot of the feedback is they get too big and we have to chop them down. So there's another battle to be fought there, but many of the plantings are absolutely magnificent. and they make a very good roadside. They could be counted, I think.
So much of our focus in climate and carbon management is around 2030, but the world will continue after 2030. Now, what role can we see indigenous forests playing 2050 and beyond?
Well, and just talking about carbon, a mature kauri forest, old-growth kauri forest, has stored in it as much as 3,000 tonnes of CO2 per hectare, and possibly more in many places. Beech forest also, because remember, the carbon stored is not just in the wood. The forest floor has enormous, and the soil, there's enormous amounts of carbon which are accumulated over that period of time. And particularly the kauri forest has a massive amount of stored carbon. It's very, very conservative, conserving all the elements that it accumulates. So that's only one part of it. The carbon's only one part of it. The other part is the heritage value that New Zealand is a forested country. And I think most New Zealanders, when they go into a native forest, feel that this is part of their heritage. Maori certainly value all the attributes of the forest. And they use the forest for kai. They use the forest for all sorts of values. And I think most New Zealanders will. So that's one of the things that drives us. Only one of the things, but certainly an important one.
I mean, beyond the climate crisis, we have probably a larger crisis around biodiversity. And the role of indigenous forests in restoring biodiversity must be very profound.
The thing is, we have to get that resource back onto our land, onto the appropriate land use types, and then look after it. And part of it is a whole package of bringing the groups together, predator-free New Zealand, those that are trying to control the browsers, those that are concerned about the weeds that are coming into this country. So it's a whole package of measures that we need to bring together to basically make this work and try and address this major issue of loss of indigenous biodiversity.
There are four words that encompass this, and that is soils, water, biodiversity, and carbon. Those are all the things that native forests bring to us. And we've seen all of those going downhill so fast in the last 50 years.
What would success look like for you, David, if you were to look back on the efforts of Tānei's Tree Trust and research such as this? What are the wins that you would like to see happen, let's say, even in the next 5 years?
Well, I think a realisation from landowners, the general public, that natives can actually be integrated into our existing land uses, and even in our urban scapes. I'd love to see a mosaic of land uses that included a serious consideration of more natives in the landscape, and our most productive landscapes are the ones with the lowest indigenous biodiversity, and yet there are networks of roads and riparian areas and fences and remnants that are isolated that would all benefit from corridors of trees, shrubs and trees, wetlands and what have you, with riparian areas that all could be planted and managed with natives. And those sites are in pasture and horticulture for good reasons, because they are low. They tend to be lowland. They are high producing, good climates and what have you. So you're going to get your really good growth rates there as well. And not forgetting that we've got a lot of the rolling to hilly country that also there are opportunities to be integrating our native forest at scale on those erosion-prone slopes. So that's my vision, is to see more adoption of natives as a legitimate land use, along with all the other land uses that are not natives are not competing with it. They could be enhancing it, in fact.
Warwick, how about you? What would success look like for you in these next 5 years?
I'll just go back to 20 years ago when we formulated Tānei's Tree Trust. We had a mission, and that was to involve landowners, particularly farmers, into the notion that it's possible and desirable to plant native trees for all of the values, but we gave them the option of planting them for the timber values that could be harvested. And I think that was a step change in understanding. It's taken a while to imbue that into the thought processes of many people, and still we have resistance to that. These are a wonderful asset that we have in this country, and we should value them for all of the values. And that was the mission. I think we're beginning to achieve that. I really believe that the credibility of our mission is now getting there. And we've run scores and scores of workshops amongst farmers, and the word is out there, and we believe we're achieving that.
How about you, Mark?
Yeah, I don't think I've got anything much more to add. So basically, I agree with what Warwick and David have said. I think largely because some of the exotics grow so well in New Zealand conditions, they're quite unique almost in the world. There's been so much emphasis on those species at the expense of natives. So it would be good to get the balance a little bit more, more towards the natives in the future. That's basically what I would hope.
I would love to see your data be built into those lookup tables. I think that would be a win.
Yes, well, that would be something we could certainly hope will happen fairly quickly. Yes.
Wonderful. Well, thank you so much for all your mahi in this space, because, someone has to do the work of the counting, the measuring, the calculating, and it's fallen to you as enthusiasts and as scientists with a real passion for this topic. And so we are very grateful for the work that you're doing, and it's been delightful talking to you all. We wish you all the best.
Thanks.
Thank you.
Thanks, Vince.
To learn more about Pure Advantage and the work we do, visit pureadvantage.org. Watch the stunning short documentary O Tātou Ngāhere and read insights from hundreds of expert contributions that highlight New Zealand's strategic advantages by putting the environment at the centre of all business decisions. Remember to follow us on Instagram, and if you found this conversation valuable, please rate this podcast, share and subscribe. Thanks again for being on the journey with us.